Here we are at our measuring and classifying angles. Now, before we dive really deep into some of the calculations with them, we're going to go ahead and start off by just identifying the definition for even what an angle is. So an angle is a figure that is formed by two rays with a common endpoint. So if you imagine we have these two different rays extending out forever and ever in their own directions, and they're joined with this common endpoint right here. And that endpoint where they join together, we call that the vertex. So now, how we usually express these different angles is we usually precede whatever we're describing with this little symbol here, this little angle measure. Okay? And again, there are different ways on how you can present it. However, you're pretty much always using this angle measure to kind of describe that you're talking about an angle. So the first one, for example, the first bullet describes that it is a number or a letter written inside of your angle. So if we imagine looking at this figure right here, you notice that you have this angle of 1, and that's exactly how you can represent it. We're going to represent it as an angle measure 1, because again, that's that number or letter that's written inside of your angle. Now, the second way that you can represent it is by the actual name of your vertex. And so when we're looking at our vertex, remember, it's that endpoint where these two values are joined together. So for example, we see that we have the vertex of M. And so we can write that then as the measure of angle M, because that's our vertex. Now, a little bit more of a specific way, and a way that I think you're going to just generally encounter more of, is describing your angle measures based upon start, the vertex, and then your end. So for example, what I mean by that is you have your ray, and you have this point N. M is your vertex. We already know that because it's that endpoint. And then it's going through this other ray O. So to describe that, then you'd have the measure angle, or the angle rather, is starting off at N. So it's going to start off at N. And then our angle is created by going to the vertex M. And then it finishes by going through O. So this would be like your end point. So notice how it had a start, the actual angle where it's occurring, going through the vertex, and then your end point. So that would be O. Now, a very, very similar way to represent this is pretty much you doing the exact same thing, just flipping them, such then that your start is going to be O, goes through the vertex, and then finishes off through N. So what that would look like would be angle O instead, starting, going through your vertex M, and then completing off at N. So in either case, we notice though we're having the exact same angle measure, whether we're going this way or whether we're going this way. You get that same exact angle. All right. So again, those are the 4 different ways that you can express an angle. Now, the reason why we would want to know different versions of expressing those is that you can actually find the measurements of those different angles. And with that, you can kind of classify them. And that's what this definition here is describing. There are different types of angles. And based upon a smaller angle, we call that an acute angle, that has a measure that's greater than 0, but less than 90 degrees. So you can kind of see where it's this smaller angle between 0 and 90. A right angle has that perpendicular angle that we're talking about. So right here is your 90 degree measure. Notice how we have 2 rays. A is acting as your vertex. You have that 90 degrees occurring. An obtuse angle has a measure that's greater than 90 degrees. So if we imagine this is 90 degrees, notice how this angle is bigger than 90 degrees, but on the other hand, it is less than 180 degrees. So this would be your measure of that obtuse angle right there. Notice how it's bigger than 90 degrees, but smaller than 180. And then finally, when we have a straight angle, there it goes through on one side of the ray, and then passes through your vertex A, and then just keeps going in the other direction. That has a measurement of 180 degrees. You can imagine that as just kind of a straight line. Okay? Now, this is just classifying our angles based upon their angle measures. In this short video, this 3-minute video, it's going to describe how to actually measure those angles using a protractor. So go ahead, take a look, and it's going to really help out so we can talk about our examples.